Good day, viewers all over the world. Today, we want to start linear non-homogeneous differential equations. Linear non-homogeneous differential equations. When I introduce linear differential equations, I said they are of two types. It can either be linear homogeneous differential equations or non-linear homogeneous differential equations. That is, if you check the past videos, you realize that there we have L of y to be equal to 0. That is, when you have second order or higher order linear homogeneous differential equation, what you are going to get at the right hand side will be 0. What you have at the right hand side will be 0. So in that case, that is an example of linear homogeneous differential equations. And we know the method of resolution. Now we are going to do that. If you have that, we are going to convert that differential equations to auxiliary equations in form of quadratic equation. You solve. Then there's a way we write this total solution y to be equal to the total solution. But in this case now, we want to talk about non-linear differential equations. That is, linear non-homogeneous differential equations. The general solution to linear non-homogeneous differential equations is given as this. It's given as what you have here. That is, in this case now, there are two things that are involved. The first one is that when you have non-linear homogeneous differential equation, when we have linear non-homogeneous differential equations, our L of y will be equal to phi. That is, the right hand side will not be equal to 0. In case of homogeneous, the right hand side of that differential equations will be equal to 0. But in case of linear non-homogeneous differential equations, the right hand side will not be equal to 0. So we'll be required to find two solutions. The first solution is a complementary solution. When the right hand side is equal to 0, the general solution will be complementary solution, which is denoted as y subscript c. But in case of non-homogeneous differential equations, we are going to have two solutions. We have two solutions. We have y subscript c plus y subscript b. Y subscript c is the complementary solution or general solution to linear homogeneous differential equations. That is, when we have non-homogeneous differential equations, we can't solve the differential equations directly. What we are going to do is that we remove whatever we have at the right hand side. We change it to 0. We go ahead and solve and first find the complementary solution. Once we get this complementary solution, we now use the complementary solution to generate the particular solution. So if you now have, if you have gotten the value of complementary solution plus the value of a particular solution, that will represent the general solution to non-homogeneous differential equations. So y subscript c is the complementary solution or general solution to the linear to homogeneous equation this. Then y subscript p is the particular solution. So under non-homogeneous differential equations, there are two solutions that will be involved here: complementary solution and particular solution. So the addition of the two solutions will actually give us the general solution to non-homogeneous differential equations. So how do we of course we have videos on how to find the complementary solution. That is, complementary solution means that we remove whatever you have at the right hand side, change it to 0. So that non-homogeneous equation has become homogeneous. We go ahead and find this. We know what to do if we want to find the complementary solution, or which is otherwise known as general solution to homogeneous differential equations. Then how do we find the particular solution? That is the bone of contention here. Okay, how do we find particular solution? Then there are two methods that we are going to do. We are going to discuss in this process. There are two methods that we are going to discuss. The first one is that if you want to find the particular solution after you must have gotten the value of the complementary solution, the first method that we can use is called the method of undetermined coefficient. We can use the method of undetermined coefficient to find the particular solution. We can use the method of undetermined coefficient to find the particular solution. That's the first method. Or we use what is called the variation of parameters. That's another method. Is that you use this or you use this. So if you want to find, of course, you must have gotten the value of complementary solution. Then once we have gotten the value of complementary solution, how do we find the particular solution? In order to find a particular solution, there are two methods that we can apply. We can apply the first method, which is called the method of undetermined coefficients or variation of parameters. Undetermined coefficients or variation of parameters. So the method of undetermined coefficients or variation of parameters will enable us to obtain a particular solution, YP, once the complementary solution is known. So let's take note that if you are given second order or higher order linear homogeneous differential equations, two solutions will be required. The first one is called the complementary solution, which represents the general solution to linear homogeneous differential equations. Once we have gotten this complementary solution, we can go ahead and find a particular solution. Then if you want to find a particular solution, there are two methods involved. Is that you use method of undetermined coefficients or variation of parameters. So once we find this second solution, which is particular solution, the addition of the two solutions will now give us the general solution to non-homogeneous differential equations. So that is what will be required. So in our next video, I'm going to start with the method of undetermined coefficients to find particular solutions. We see how we're going to get it. We are going to use the same example. I will use the same example to find these two different methods, but same example to find a particular solution, so that we will see the justification that we can actually use the two methods. Thank you.